Hello, welcome to IBCC channel. In this video, we will give the overview of the BGP. So the primary function of the BGP system is to exchange network reachability information with other BGP system. A BGP router includes at least two categories informations. The first is a list of an autonomous system that network reachability information traverse and other associated BGP attributes. So another part is a network prefix. So we can see the BGP is a path vector routing protocol, since the BGP router maintains a list of the autonomous system that the network reachability information traverse. Let's use this diagram to explain how the BGP works. This diagram illustrates the current internet structures in the high level. So current internet have ISPs. ISP can be divided to the three types. So the very large ISP called the Tier 1 ISP. They are globally rich. So they are interconnect each other. And second is called the Tier 2 ISP. It's a large regional ISP. So they are interconnect each other. Also, they are connect to the Tier 1 ISP for the upstream. Now there's a Tier 3 ISP. That was a small ISP. Small ISP most likely they connect to the region ISP for its upstream link. So this diagram here, we assume there is a network x.y.0.0.16 reside in the AS577. So for the ISP, the AS577, to let other ISP to know he owns the x.y.0.0.16, he need to advertise this information to all his BGP neighbors. So after he advertises this information out to all the BGP neighbors, eventually in the right hand side you can see another ISP called his AS number is 812. So this AS will get this routing information from BGP. They will get two paths. One is from top, another from the bottom. So the two paths are illustrated here. So you can see the two paths. The first path, there is include four AS number here. This 4S numbers is called the AS path. The second route just include one AS number. That's also the AS path. So since the BGP is a path vector routing protocols, so from the AS A812 perspective, they will choose the shorter AS path as the best route. So they will choose the bottom route as the best BGP route. So that means this AS577 advertise routes to the AS812. The 812 get a best route. Then AS812, if they want to send traffic to the x.y.0.0.16, he will send the traffic direct to the bottom of this link, go to the AS577. So this is a pictures just gives a very high level of how the BGP works and what the BGP routes looks like. So next we are talking about the iBGP and the eBGP. So BGP used within an autonomous system is called internal BGP, denoted as lowercase I, capital BGP. So the iBGP neighbors can be directly connected or indirectly connected. So in contrast, a BGP used between autonomous systems is called external BGP, wrote as the lowercase e capital BGP. By default, eBGP neighbors need directly connect since the TTL of the BGP message is sent to 1. So this message just can propagate 1 hop away. This default behaviors can be changed by user command eBGP multi-hop. So the diagram below illustrates this the situations. So you see this AS called AS100. So there are several routers inside AS100. So within the same AS numbers, if two routers run the BGP, that's called iBGP. So here I illustrate the iBGP can directly connected, also can be indirect connect like this one. They go to some kind of cloud, IP cloud, as long as they have network reachability. So you can build the iBGP between these two routers. So eBGP here is between the different AS. So the two routers each belong to its own AS, and the AS have different numbers. So this BGP between the two routers called eBGP. So next we'll talk about the BGP neighbors and the TCP port. BGP neighbors, also called BGP peers, are established by manually configuring the neighbor among the routers. So remember, the BGP neighbors have to be manually configured. There's no automatic command to configure that. BGP uses TCP as a transport protocol. BGP uses TCP port 179 to communication with other routers. So how it works? The router first establish a TCP session with his BGP neighbor. The destination port is 179. So then the routers open a BGP sessions over this TCP session to exchange a BGP message with its BGP neighbor. So BGP routes are exchanged by BGP update message. So all the BGP routes will be exchanged by all the BGP routes will be carried by the BGP update message and exchanged between neighbors. So, since BGP uses TCP as its transport protocol, it requires the IP connectivity between two routers that need to establish BGP neighbors. So this need to be remembered. BGP need IP connections between the two neighbors. So BGP neighbors send a keep alive message every 30 seconds by default to maintain the connectivities. So this is all the basic, very basic BGP behaviors. So bottom, I just use a diagram to illustrate. So take a look at this one. In the AS100, there's two routers, router 1, router 2. Router 1, router 2, in order to establish BGP sessions, they have to have the IP connectivity. If no IP connectivity, there's no way to establish BGP. So after the IP connectivity was ready, then you can build the BGP sessions. BGP sessions or use a destination port, so 179, and source port can be any available source port to establish TCP session. After TCP session established, BGP can compare that send BGP message to compare if everything's matched, the BGP session will be set up. So that's pretty much is a very high level of the overview of the BGP. So This brings the end of this videos. In the next video, we will talk about the BGP method in depth. So thank you for watching this video. If you like this video, please give a thumb up and subscribe my channel. Thank you.